As I said previously, students, an email that I sent you recently, instead of a lecture, I'm going to work through the homework problems that I've assigned each week. Hopefully this will help you along with the videos and the various work that you're doing in order to help you keep up with the things that I think you need to understand before you finish the year. The grade, however, will now be based on the quizzes and the final examination. Starting with this homework assignment, you will not have to turn in any future homework assignments, and all your grades will be from a compilation of the quizzes, which will count about 60 or 65%, and the final examination, which will count for the rest. So that you're aware, we're doing this group of homework problems today on this video. There'll be more than one section of this video because I like to not have them more than 15 minutes or so long. And you may notice some degree of jerkiness because from time to time I'll have to do some calculations and things, and I'll try to edit those pauses out, but sometimes there's jerkiness associated with that. So without further ado, let us start. We'll start with page 254, numbers 1 through 3. So number 1 states the following: find the speed of a wave with a wavelength of 8.2 meters and a frequency of 75 hertz. So the wavelength is equal to 8.2. Sorry, I'm using a mouse here until I can get my pen charged up, so I'm not quite as good at it. And the frequency is 75. I think that's right, 75 hertz. Hertz is just another term for oscillations per second. And so the other way of looking at the term hertz is to see it as oscillations per second. So the question is, what is the speed of the wave? And the equation for that is that V is equal to wavelength times frequency. So in this case, you're going to take the wavelength, which is 8.2, and multiply that by 75. And that's going to equal 615. And the wavelength was in meters, and this is per second or hertz. So it's going to be meters per second. So that's the answer to the first problem. The second problem states the following: what is the wavelength of radio waves that have a frequency of 530 kilohertz, that is 5.3 times 10 to the 5th hertz, and a speed through air of 3 times 10 to the 8th meters per second? So 3 times 10 to the 8th meters per second is the speed of light. So the frequency, as it says here, is 5.3 times 10 to the 5th hertz, and the velocity is 3 times 10 to the 8th. So if we take this equation here and we rearrange it to solve for wavelength, we see that the wavelength is going to equal the velocity divided by the frequency. Which means if we put 3 times 10 to the 8th and divide that by 5.3 times 10 to the 5th, we get the following. If you take 3 and divide it by 5.3, you get 0.566. you get 0.566. And then when you divide, you subtract the exponent. So you're going to subtract this 5 from 8. So that's going to be times 10 to the third. But proper scientific notation leaves you with a number between 1 and 10. So you need to move this decimal over one spot so that it's 5.66 times 10. And you moved it to the right one space, so you have to decrease your exponent by 1. Times 10 to the 2, or 566 meters. And that's the wavelength of this wave. The last problem on this page, what is the wave frequency of a wave with a wavelength of 6 centimeters and a speed of 330 meters per second? So that's the speed of sound. 330 meters per second is the speed of sound at 0 degrees. So we have a wave length of 6 centimeters. Now, you always have to get suspicious when they change units on you, because here you're going to have mixed units. The velocity is 330 meters per second. So you're going to have to do one of two things. You're either going to have to change the velocity into centimeters per second or the wavelength into meters. And personally, I believe it's easier to change this to 0.06. I'm not sure what that is. 0.06 meters. And that's just, it's a centimeter is a 1/100th of a meter. So this is 0.06 meters. Again, you rearrange this equation, but now solving this equation for frequency, you end up with frequency is equal to velocity divided by the wavelength, which is going to equal to 330 divided by 0.06. And if you do the math here, you get 5,500 hertz, or 5,500 cycles per second, which is what hertz means. So there are the three problems. The first three problems that you were asked to do. Now let's look back at the assignment sheet. The next one is on page 257 and 258. And these are review questions, okay? So since these are just questions that you can look the answers up in the book, I am not going to go through the answers to these questions. In other words, questions like number 1, what is a wave? If you go back to, say, page 254 and read that part, it will tell you what a wave is. Or you can go even further back and says that a wave, actually a better way to find it is on page 251, where it says a wave is a periodic back and forth motion or oscillation. So I'm not going to go through 1 through 10 because you can look those answers up in the text. So the next would be to pull the handout. So let me pull out the handout here. Okay, here is the handout. And so we're going to work through the remainder of the homework that we're going to work through is these problems on this handout. The first problem states that two sailboats are anchored 10 meters apart. As a series of waves passes, the boats bob up and down. When one is up, the other is down. What is the wavelength that would produce this effect? Explain. If you can come up with more than one answer, use the largest one. Okay, well let's take a look at this. And one of the things that I do with these kind of problems is I draw a picture. So here's the wave. And basically they're saying that you have a boat here. My boats are much like my cars, which are the boat equivalent to an element. And here's a boat here. And they're saying that whenever this boat is up, this boat is down. And then as time passes, this boat is up and this boat is down. Well, a wave is defined as the distance from peak to peak or trough to trough. Okay, so they've asked us here, it says, what is the wavelength could be produced by this effect? Since the boats are 10 meters apart, this distance is 10 meters, so the wavelength is double that. So the wavelength here is 20 meters. Was it meters or feet? Meters. And so the explanation here is that by definition, the wavelength is the distance from peak to peak. And if one boat is up when the other is down, then that means that the distance here from peak to trough is half of the wavelength. The wave going this way. And so you have the 10 meters is half of that. So your answer is 20 meters. Now, number 2 says the following. As a sailor on one of the boats, you notice that you go from the highest position to the lowest position and back to the highest position in 10 seconds. What is the period of the wave? What is the frequency? And what is its velocity? Okay, so first of all, let's go back to our picture, and you're standing here. And basically what it says, if you read this carefully, it says you go from the highest position to the lowest position and back to the highest position in 5 seconds. So you go from here to here in 5 seconds. Now, all you have to do is look back in the chapter and find that the period is the time it takes for one period, which is frequently capitalized capital T, is the time it takes to complete one wave. And that they've just told you that time is 5 seconds. So it takes 5 seconds to complete the period. The next question is, what is the frequency? Well, the frequency is 1 divided by the period, or it's the time or how often per second or per whatever time period, but in this case per second, a wave repeats itself. Okay, if it takes 5 seconds to complete one full wave, then it takes 1/5 of it's 1/5 of a wave is completed each second. If it takes 5 seconds for one total wave to get completed, then 1/5 of a wave is completed per second, or 0.2 cycles per second, or hertz. So the period is the time that it takes to go through one complete wave, and the frequency is 1 over the period, or how many waves are completed per second. The third question, what is the velocity? Okay, remember from up here, the velocity is the wavelength times the frequency. So V is going to be the wavelength, which we've calculated as 20 meters, times the frequency, which is 0.2. And so 20 times 0.2 is 4 meters per second. And that's number 2 on the handout. Number 3. A certain water wave has a wavelength of 25 meters in a period of 4 seconds. What is the velocity? Okay, first of all, you know from the equation up here, right here, from this equation, you know that you cannot calculate the velocity of a wave from a period and its frequency. You need the frequency and the wavelength. And so you have to change this period to the frequency. And I already told you that the frequency is 1 over the period. So the wavelength times 1 over the period will give you the velocity. So let's do that. V equals the frequency times the wavelength. And we know that frequency, whoops, I said frequency and did what? And we know that the frequency, let me see if I can Jabberwocky this into a frequency, is equal to 1 over the period. So if we put this in for F, we get V is equal to 1 over the period times the wavelength. And 1 over the period is 1 over 4. And I believe the wavelength was 25, if I remember right. I'm going to go back and look in just a second. And so it's 25, so 1/4 times 25 is 6.25 meters per second. So that's the velocity on this one. Okay. I'm going to stop right here and we'll finish the handout problems on the next part of this video.